All right, this is 14.7 going into work problems. And so, what I want you to think about when you have work problems, you're going to have a table that you're going to make, and one column is going to be your workers. So, those are either going to be people, they're going to be machines, they're going to be pipes, something that's going to be working, and you have an individual working. And then, what you usually want to know is what it's going to take for the worker to do together time. Then you're going to have a column for the given time. And then you're going to change that given time to a unit fraction time, okay? And the way that we're going to change that fraction, it's always going to be time in 1 hour. And unit means uni, which means that our one is going to go on the top. So what we're going to have in our column is we're going to have our worker 1 or pipe 1 or whatever you have. They give you an X time, and then you're going to change that time into 1 over X. Now, I'm just using variables here, but it'll make sense once we get actual numbers in here. Then we might have worker 2, and they're going to have a time, Y time, and then you'll change that into 1 over Y. And then usually the last row is going to be the together time, and we'll say that together they can do the job in Z. So things to note here is that the together time should always be less than the fastest time given. Okay, which makes sense. If one person can do the job in 6 hours and the other person can do it in 10 hours, you would expect that they can do the job together in less than 6 hours. Okay, so this is what we have. We have an electrician and we have her assistant. Okay, so I'm going to make a column or make a row where I have electrician, I have the assistant, and I have together. So what I'm going to do is I'm going to write in what's given. The electrician can wire the house in 12 hours. The assistant takes 18 hours, and we want to know how long it takes them together. So there's the given times. Where my equation is going to come is from the unit times. So we turn 12 into a unit, which means 1/12. We turn 18 into a unit time, which is 1/18, and we turn the together time into a unit time of 1 over X. And so the electrician's time plus the assistant's time should always equal the together time, okay? So now we have to find the LCD between 12 and 18. So if I do that, I'm going to write 12 as 2 times 2 times 3. And 18 is going to be, let's see, 9 times 2. So that would be 2 times 3 times 3. So I need 2 2s and 2 3s. So my LCD is going to be 36. 2 times 2 times 3 times 3. So I'm going to multiply every term. Oh, and don't forget, I also need an X. Sorry, forgot about that. I also have a denominator that has an X. So that needs its own column. So my LCD is going to be 36X. So 36X times 36X times 36X. So what happens is this 12 goes into this 36 and leaves 3. 3 times X times 1 is 3X. This 18 goes into this 36 and leaves 2. And 2 times X times 1 is 2X. And these X's cancel, and I get 36. So now I have 5x equals 36. Divide through by 5, and x equals 7.2 hours. And it's okay to leave or to get decimals, or you could leave it as 36 over 5, okay? All right, now this one is a little bit different because of the way that it's wording. We have to define the variable. So we have a mom, we have her son, and we have together, okay? Now they tell us that the together time, they can carve it in 3 hours. So there's my first number. But the relationship between the mom and the son is given in that first sentence. It says the mother can carve the pumpkin twice as fast as her 8-year-old son, okay? So you have to be careful. It means that the mother does it in a certain time. Her son is going to take 2 times as long. So the X is actually the mom, and the 2X, 2 times longer than the mother, is going to be the son. And so now we turn them into units. Mom's unit time is 1 over X. Son's unit time is 1 over 2X. And the together time is 1 over 3. So the mom's time plus the son's time equals the together time. My LCD is going to be, I need a 2, I need a 3, and I need an X. So my LCD is going to be 6X. Multiply by 6X, and that's going to eliminate this X, and that leaves 6. This X, 2 goes into 6 and leaves 3. And 3 goes into 6 and leaves 2. So we get 9 is equal to 2x. So then I divide it by 2. And so the mom's time is going to be 9/2, or 4.5 hours. And the son's time is 2 times that, which would be 9 hours. Okay? Now, this one is a little bit tricky because we've got a pipe. We've got one pipe that's filling the pool, the inlet pipe, and we've got one pipe that is draining the pool, the empty pipe, and then we've got together. So I'm going to put the inlet as one row, and that's filling the pool. And then I'm going to put the drain, which is the outlet or the emptying of the pool. And then I'm going to make the together, okay? So the given time says that the inlet pipe can be used to fill the pool in 33 hours. The drain pipe can be used to empty the pool in 42 hours. Now, this next sentence is going to come into play in just at the very end of the problem about the pool being half filled, but we want to know how long would it take them to fill the pool and drain the pool at the same time, okay? So we're going to turn these into units. 1 over 33, 1 over 42, and 1 over x. Now, this problem in particular is a subtraction problem because we have the time or the part filled minus the time of the part emptied, and that's going to equal the part filled together. Okay, so this one is a subtraction. So we take 1 over 33 minus 1 over 42 is equal to 1 over x. Now, finding an LCD for this may be a little challenging. We're going to break 33 up into 3 times 11. We're going to break 42 up as 6, which is 3 times 2, and then we have to multiply it by 7. And then, of course, we also need an x. So I'm going to highlight. We need 1, 3, 1, 11, 1, 2, 1, 7, and 1x. So when I multiply all of those together, I get 462x. So I am going to multiply by 462x, all terms. So 33 goes into 462 14 times, and I'm left with the x. 42 goes into 462 11 times, and I'm left with the x. And then the x's cancel, and I'm left with 462. So combine like terms, I get 3x equals 462. Divide by 3, and x comes out to be 154 hours. But the pool is already half filled. So we have to take half of 154 hours, and that tells us that it's going to take 77 hours to fill and drain so that you get fresh water in your pool. So that finishes the work problems of 14.7.